All right, you guys can see the topic of this unit is quadrilaterals. There are a lot of quadrilaterals we got to go in depth and talk about with. That's why this unit's going to take us past break into January, because there are a lot of quadrilaterals to talk about. We are going to talk about a specific one today, but before I do that, I want to introduce you to all of the quadrilateral family. So here's a family tree right now. Right at the top, here's your quadrilateral. Everyone says, oh, a square. Okay, that's a type of quadrilateral. That is a type of quadrilateral. Quadrilateral, 4 sides, all their interior angles add up to what? Anybody? 360. That's the only thing I know. 4 sides, that all the interior angles add up to 360. Now, as you guys can see, the family is broken up into 3 different parts. 3 different. Let me introduce you to the first family. With the big dog himself, parallelogram. The parallelogram right at the top. And there's a few other people in that family. Anybody want to take a guess of the other people in that family? The parallelograms. Anybody at home in here want to take a guess of the other figures in the parallelogram family?
I think there's a rectangle.
A rectangle. Rosie the rectangle. Please be respectful. Rosie the rectangle. Yes, the rectangle.
I think the other one's a rhombus.
Randy the rhombus. Yes, the rectangle and the rhombus. Correct. And then there's the golden child of the parallelogram family. She has everything. Everything. The perfect one. Maybe some of you can relate in your own family. I certainly can. All right, and that would be Susie, the square.
You can look these on the spot.
I've used these every year. Susie, the square.
Parallelogram have a name?
Papa, because he's kind of like the leader.
And
Did something happen to
OG.
the mother?
I don't know. Might just be a single parent family. I don't know. And don't give me, every year, well, if these are the kids and then they're putting in the square, that's kind of, don't go there.
Well, there's no
Don't
line
either.
between the
Right.
two, so you can assume it's
Yeah,
not.
okay, yeah. All right. But yes, the square has everything. Now, why are the parallelograms grouped separate from the other 2? Great question. Here's why. Because everyone in the parallelogram family is the only one that has both pair of opposite sides parallel. Okay? Nobody else in the quadrilateral family has both pair except the parallelograms. That's it. All right. Now let's go to the second family in the quadrilaterals, and that is, anybody by the looks?
Trapezoid?
The trapezoid. So you got Tony, just the trapezoid. And then you have the souped up, the 2.0 version of a trapezoid, which is Isaac, the isosceles trapezoid. He's got a little bit more properties than just the trapezoid itself.
Does he have a name?
Isaac.
Oh, right.
I was
writing the other names.
Okay,
down.
all right. Now, why are they grouped separately? They don't have 2 pair. They only have 1 pair of parallel sides. That's it. All right, so the trapezoids only have 1 pair of parallel sides. And then there was the outcast, the only one. Now some of you probably could relate, right, of the family. I know my sister could. All right. What, too harsh because she's not here? Get over it. She knows. All right, it's tough to live up to this. And that would be Kyle, the kite.
Does that have just a sideways rhombus?
Nope. It does not have the same properties as a rhombus. Why is the kite all by itself? 2, 1, no pairs of parallel sides. No pairs of parallel sides for the kite. Okay? So these are all the figures we're going to go pretty in depth in studying. All figures have properties. All right, so that's why it's going to take so long to get through this unit, because not only do we have to go over properties, algebra, but we also have to do proofs with them as well. Yes, yes. No, none today though. So you get a nice weekend. None today. I'll crash your dreams on Monday. Yes, Omni?
Could you say that a square is just a regular rectangle?
It's a regular quadrilateral. True, but it's also a regular quadrilateral, right? All sides and all angles are equal.
That's what's called a square.
Okay. Yep. Everybody good?
Can there be a regular quadrilateral that is not the square?
What's regular mean again? All sides and all angles are equal, which is the definition of a square. For 4 sides, right? All right, today, tomorrow, and Tuesday, really right up to our first quiz next week, our sole focus is on the parallelogram by itself. Okay, we will not talk about rectangle rhombus till after we've gone through a lot of info on the parallelogram. So here's the deal today. Today I want to show you the 5 properties of a parallelogram, then use them in algebra, and then we're out. We're done. First thing we got to talk about, though, is labeling any quadrilateral. Labeling. Because when you guys had triangle ABC, it didn't matter where you put A, B, and C. The order did not matter one bit. It does now. All right, so if I'm going to call this parallelogram ABCD, the order of the letters will matter. You cannot just plop A, B, C, and D anywhere you want. Here is the rule when you label a quadrilateral. You can start anywhere. Start at any of the 4 vertices, so put A anywhere. From here, though, you have to go clockwise or counterclockwise. You cannot jump diagonally. So I cannot go A, B. No. We got to go clockwise or counterclockwise when I label from my starting point. All right, guys? Do not jump diagonally. All right. Here we go. Everyone always asks, how do I do well in this unit? Know your darn properties. If you want to have any chances of success in this unit, know your properties. That's it. That's all I'm going to tell you. Know your properties. First property you already know. Why do I group all the parallelograms together? Because they have both pair of opposite sides.
Parallel.
Here you go. So my first property, opposite sides are parallel. And I'm going to not only write it down, but also label my diagram with it. There we go. So now my D went there. Opposite sides parallel. Here we go. Good. When would you ever have to use this property? Remember we did a whole unit on parallel lines? You remember the names of special angles that are formed? Anybody throw a couple at me? Special angles formed by parallel lines? You're going to get alternate interior again. You're going to get corresponding again. You're going to get same side interior again. Okay? That's why you need to know the opposite sides are parallel, because you're going to see those types of angles again. All right, let's keep rolling. Guesses now. I'll turn it over to you guys at home. Guesses on more properties. What's it look like? Guesses, Gideon.
Angle A and angle C are congruent.
Okay, angle, what about D and B?
Those are also.
Okay, A and C are congruent, so are D and B. We call those opposite angles. Opposite angles are congruent. Opposite angles are congruent, yes. Other properties you think exist? Sophia, what's up?
DA and CB are congruent, and GC and AB are congruent.
Opposite sides are congruent. Boom. Opposite sides, nice job. So I have DC and AB, I have DA, and I have CB. Perfect. I think you guys can get the 4th one. Maybe not. You probably won't get the last one because you don't see it on here yet. I haven't drawn them in. Quincy?
Angles that are on the same side are supplementary.
Okay. You guys remember parallel lines? Same side interior? Ready? D plus A equals 180. A plus B equals 180. B plus C equals 180, and so on. I'm going to call those in this parallelogram, instead of same side, I'm going to call them consecutive. I think that's easier for you to remember and to visualize. Consecutive angles are supplementary. Okay? And again, consecutive, A and B, B and C, A and D, those are consecutive. They add up to 180. All right, the last property. I'm not even going to ask for guesses. Can you guys tell me from the Ed puzzle video what I'm drawing in right now? A vertice connected to a non-adjacent vertice. That's called the diagonal. There's two of them in a parallelogram. There's two of them. I'm going to put markings on them. You tell me what they do to each other. Ready? 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Bisect each other. Diagonals bisect each other. They cut each other into two equal parts. So there's the fifth and final property. Diagonals bisect each other. Again, key to success in this unit, know the properties. All right, before I move to problems, one more here. I want to stick on diagonals bisect each other because I want to challenge you honors kids. See the point where they intersect? Give me a vocabulary term. Don't yell anything out here. Just think about it. That's the what of each diagonal right there. That is the what. That point of intersection is the what of both diagonals. Congruent, 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 congruent here. Got it, Atticus? Midpoint. Perfect. All right, guys, that's the midpoint of the diagonals. That's just going to help you out on one of the problems tonight. Hey, you guys at home, we okay here on the properties? Because now we're going to do algebra ones where you guys are going to help me out too. Any issues in here, guys? All right, let's get to the algebra. All right, using your properties. So I got number one, just find x. That's it, find x. So just so you know, 10 is referring to this piece of the diagonal right there. That's 10 right there. Okay, I need an equation and be ready to back yourself up. All right, first, equation. Here we go. Let's rock and roll. Quincy, you're up. Equation to solve.
10 equals 2x minus 4.
Okay, I'll get back to how you know y in a second. Let's just find x here. So everyone moves everything around. I got 14 equals 2x. X equals 7. Okay, now it says theorem used. How did Quincy know that? Quincy, how'd you know to set them equal? What property of the 5 did you just use?
Diagonals bisect each other.
Diagonals bisect each other. So here's what we're going to write. And we're going to write it this way because on Monday, we're going to write it in the reasons column this way. And that is, well, this is, by the way, hopefully you guys like this as much as I do. Parallelogram? You like that, Sophie. I could tell. You like it. Yeah?
It's just,
It's
it's a parallelogram.
instead of writing, you don't have to write out the word parallelogram. You let everyone at home, huh? How about that? Parallelogram? Maeve, you pick that one up there? Good talk. All right. Parallelogram implies, now tell me the property. Quincy just said it. Diagonals bisect each other. That's my shorthand for parallelogram. You don't want to admit it, you love it. All right, that's exactly what we're going to start writing on Monday, if I ever use that property in a proof. All right, let's start rolling here. Let's start flying. 2, I don't need to set up an equation, I hope. What's the value of x and y? Oh, here we go. Atticus, what do you got? Value of x for this one? 16, done. X equals 16. Property that you use, parallelogram implies, what property did you just use?
Opposite sides are congruent.
There you go. Opposite sides congruent. We okay at home? All good? All right, couple more. There's only so much I can do with the sides and diagonals. So yes, you are going to see some repetition. All All right, number 3. Can you have somebody give me an equation to solve for 3? Use a property. Atticus, we're good. I'll get back to you later, probably. Caroline, there we go.
3x minus 2 equals 4x minus 10.
Yep, how'd you know to set them equal?
Because diagonals bisect each
There you go. Parallelogram implies diagonals bisect each other. And then you guys can go ahead and let's see, what do I get? X equals 8. And yeah, it's repetitive. There's only so much you can do with the sides and diagonals. And then finally here, I say finally, but we got 2 more with the sides and diagonals. 4x plus 3 is just this piece, everyone, all right? That's just this piece right here to the intersection point. And ik equals 35. The whole diagonal is 35. So next up, equation. Oh, finally, here we go. Hannah, going home now. You got an equation for me, Hannah, I could set up? There you go. 2 times 4x plus 3 equals 35. You could also take a half of 35 if anybody was feeling crazy and set it equal to 4x plus 3. How'd you know to take twice 4x plus 3? What property are you using, Hannah? Yep, diagonal. Wait till we get to the angles, then it's going to get crazy. Diagonals bisect each other. Oh, we get a little decimal action here too, huh, kids? Don't freak out, and that's 8x. What is that? I forget. 3.625, anybody? Sound good, Caroline? 3.625? Guys at home, all right? How about in here? All right, moving on then. One more sides and diagonal problem. TR 14, ME 31. All right, find TI. I think I gave you a little too much information here, but let's see if you know which one I don't need. Don't feel like you need to use all of it because I think I gave you a little too much here. A little extra for you. All right, little help. How do I get TI? Yeah, there we go. Luke, how are we getting TI?
2 times 14.
2 times 4. How'd you know 2 times 14?
Because it's the median, so
Whoa, me? What vocab are you busting out here?
R is the midpoint of TI, so.
Okay, yep. So if this is 14, diagonals bisect, so that's 14. Yep. No theorem needed here. No theorem needed because there didn't say theorem. Why does it on your sheet?
No.
No? Okay, so we don't write one down. There you go. All right, everyone comfortable dealing with the sides and the diagonals because now it's going to get a little nuts with the angles. All right, I am going to do number 7 with you, and then you have 6, 8, and 9 on your own to end class. All right, 7. Before we start, let's make this point clear. You do not have to go in order. 1, 2, 3, 4, don't you think? You don't have to go in that order. Guys, you find what you can. Find what you can first. And if that means it's a blank angle you find it. Find whatever you can. Do not go in order. Find a blank angle if it leads to a numbered angle. And final thing, don't think you just have to use parallelogram properties. Use anything you know about geometry. Linear pairs are supplementary. Vertical angles are congruent. 180 degrees in every darn triangle. Use anything you want. All right, just not parallelogram properties. All right. So let's do number 7 together. And just like I said, find any angle you want. You tell me which angle you want to find first in number 7. Oh, here we go. Emma. Hello, Emma. Hello, Mr. Carly. I'm doing well. Thanks, Emma. Yep.
Hi.
Good. Yep. No, sorry. Too late, Emma. Too late. What angle are you going to find?
I just said measure angle 3 is 12 degrees because I did 180 minus 113 minus 25.
12 degrees?
Yeah.
12?
Not 12, sorry, I hit flat.
Yeah, one job.
I'm sorry.
Don't get rattled. Let's go. Regroup. You're rattled right now.
22.
22. And again, one more time. How'd you do it?
I subtracted 113 and 45 from 180.
Yeah, that's fine. Or did anybody take a look? 22 and angle 3 are what type of angles, everybody? Alternate interior. So that's another way to do it. It doesn't matter how you get there, though. Okay, 22. I always like to put that in the diagram because it may help me out later. Next angle you want to find. Ooh, somebody. Audrey.
Angle 2.
You want to find angle 2? You got it. What is it?
It's 45.
How? How'd you know that? Back yourself up.
Because they're alternate interior.
Yeah, 45 and angle 2 are alternate interior. They're congruent. Perfect. One way to find it. All right, that's 45. So now let's get to angle 1. Again, look, I love it. We don't have to go in order. Oh, there we go. Anthony, how about angle 1, boss?
I said 113 degrees
Back yourself up. Why?
because opposite angles are congruent.
He used the property. Parallelogram, opposite angles are congruent, or he could have used 180 degrees in a triangle. Perfect. Great job, Anthony. All right, you guys are on your own. I'm going to write the answers up as you guys work so you guys can check them. And if you finish early, feel free to get the online textbook out and get the answer key, get the homework started. Whew. Again, find blank angles if it helps you get to the numbered ones. That's fine. Know your properties. If you don't know where I came up with an angle measure, please ask. I will show you how. Go ahead.
Sure how you got angle 3 and angle 4. I'm trying to reason that angle 2 and angle 4 are corresponding angles.
For which one?
6.
For 6?
8, sorry.
8? Well, 72 and 3 are linear pairs. Right?
Yeah.
There's no correspond. There's only alternate interior in that diagram. There's no corresponding. So 40, and this angle right here is also 40 because it's alternate interior. And then once I knew the linear pair to 72, I could get angle 4.
Alright, yeah, I didn't want the 1 in the beginning.
Yep. Really, the only thing, I wouldn't even look for corresponding, Sophia, yet. I would just stick with the alternate interior for now. I'll put it back up in a second. Just let me stop this.